And Common Sense Matters is on the air. Good morning. How are you?
Good morning. I'm good. Good as can be.
Huh?
Good morning and welcome to Common Sense Matters, sponsored by the Franklin County Democratic Party. My name is Sandy Rice, and today's topic is climate change and how it is affecting our Tennessee wildlife, trees, plants, rivers, streams, air, and people. My guest is Dr. John Evans, head of biology at the University of the South. Dr. Evans, tell us about yourself, what you teach at the university, and what you've been researching.
Okay, well, I'm really happy to be here.
Thank you.
Via phone, doing my social distancing here.
Yes, thank you.
I teach ecology and conservation biology at the University of the South, and I've been here since 1994. I do research on forests and how forests respond to long-term change that mostly is a function of how people interact with these systems. And I've done a lot of work here on the Cumberland Plateau and also on the coast in barrier island systems.
Oh, okay, good. So we're going to talk about climate change today. That sounds right up your alley. Can you give us, what's your definition of climate change?
Yes, well, basically it starts with the root of climate change, and that is why we are experiencing it, and that has to do with the burning of fossil fuels. And fossil fuels, of course, are our major source of energy on this planet. Petroleum, gasoline, coal, methane, and these are carbon compounds that were put down into the ground many millions of years ago in large amounts, back when plants were taking carbon out of the air, and in these geological deposits have been stored away for a long time, and that carbon has been safe where it was deposited. But when we started taking it out and burning it, we release it into the air in the form of CO2, carbon dioxide, and carbon dioxide is what we call greenhouse gas. And greenhouse gas is what the word suggests. It's a gas that creates an envelope around the Earth, similar to what you have with the greenhouse and glass. When you have sunlight putting energy into the Earth in the form of shortwave radiation, it gets trapped after it passes through and reflects off of the vegetation and the ground and the soil in the form of heat. And that heat, just like in your car on a hot summer day, it comes into the glass but can't get out. It builds up. And that heat is the problem with increased carbon dioxide, which is a result of the burning of these fossil fuels. There are many greenhouse gases. Carbon dioxide isn't the only one, but it's the one that we're increasing at a dramatic rate. We have more carbon dioxide in the atmosphere today than we've had in 800,000 years.
Oh my gosh, okay.
That's a long time.
Mm-hmm.
So we are dealing with the consequences of a condition on this planet that we as a species have never experienced. And what happens when you warm the Earth through this increase in greenhouse gases is that you change climate. Climate is basically two things. It's rainfall and precipitation, basically, and temperature. And the various combinations of temperature and precipitation create different kinds of climates all around the world, whether you go from the equator all up to the polar regions. It's the combination of those two factors that create the conditions that define these systems.
Mm-hmm.
And when you change the amount of heat on the Earth, you change the global temperature, you change that relationship between temperature and rainfall and how they play out across the globe. And it's that unpredictability of how those two factors play out that changes our weather. Weather is the short-term manifestation of climate. On a daily basis, we have weather. Climate is the pattern of weather that sort of transpires over many decades. And when you look back and you see how weather has played out, that tells you what your climate is. And the problem with going forward here in this world of climate change and increased carbon dioxide and global warming is that we don't know what the weather is going to be like. We don't know how climate is going to play out. And that's the scary thing about this, is that it's very unpredictable. And that's the one thing that's for certain, is that we can expect a greater unpredictability, and that has effects on ecological systems that have evolved over long periods of time, plants and animals, and fungi and bacteria that all live together in these forests and marshes and coral reefs. They have adapted to a certain expectation of temperature and rainfall and climate. Basically, there's a factor that determines the ability of that system to function a certain way. And when you change the ground rules, there are consequences, as we're seeing all around the Earth.
How long have we been able to measure, I guess, take the temperature of the Earth? Certainly not for 800,000 years, but when did we start measuring the Earth's temperature?
We've measured the amount of carbon. We can trace back and determine how much carbon dioxide has been around the Earth for a long period of time. As I said, we have a good understanding of how carbon dioxide has increased and decreased around the Earth for many thousands of years. And there's all kinds of ways in which we can do that. Most recently, we have detectors out in the ocean that sense, out in the Pacific Ocean, that sense the annual fluctuation of carbon dioxide and gives us what we call the Mauna Loa curve. It's this graph that everyone uses to track how much carbon dioxide is present on an annual basis. And we've been doing that since the 1950s, and that has told us that those monitoring stations and the tracking of that curve of increased carbon dioxide has told us that we've had this steady and accelerated increase over these many decades recently. But we can track using other mechanisms, scientific mechanisms. We can get at prehistorical carbon dioxide going back, as I said, all the way back hundreds of thousands of years. And so that's basically how, when we know that that the relationship between carbon dioxide and temperature is a very tight one.
So do we know what the temperature of either the Earth or the Earth atmosphere is now?
We do. So the temperature of the Earth, it obviously varies all across the planet.
Or the average, or
where
what
you
the
are, and
changes.
But it's the average change in temperature for any one large area or the globe as itself that is what gets determined. That it tells us whether or not there is an annual increase in the Earth's temperature over time, and it doesn't seem like a lot. So like 1 or 2 degrees centigrade or Fahrenheit, it may not seem like a lot in terms of what we think of as temperature on a daily basis. But when you look at it from the planetary standpoint over the course of a year and you compare it to previous years, that is substantial. And then tracking that increase in global temperature is what scientists do to tell us whether or not we're getting warming.
How far can we go? How hot can it get?
Well, it can get quite hot. We know in the past, in prehistoric times, when carbon dioxide, before 800,000 years ago, there were times when there was more carbon dioxide in the air than there is today, and that was a time when there were forests in Antarctica, and there were no polar ice caps, and we know it's possible that the Earth can experience larger degrees of warming than we have today, and it has. And what makes it problematic for us as a species is that this is happening very, very fast, and the consequences of that warming are tremendous to us, given all the different ways in which it manifests itself as a problem, not only to us but also to other species. And I think one of the things that we don't sort of completely comprehend is that it's not just warming that carbon dioxide has precipitated in terms of a problem. Carbon dioxide also, as it increases in the atmosphere, creates greater acidity in our oceans. So it's the evil twin of global warming is ocean acidification. So as you increase the amount of carbon dioxide in the air, there's greater amounts that dissolve into the oceans, causing the oceans to become more acidic. It's like when you blow into a cup and you have a piece of like a pH paper in there, and you can look at the pH of what happens to that water, it gets acidic. Well, that's problematic for all those species of organisms in the ocean that rely on a certain pH range in order to be able to put on their shells, something like a clam or a scallop, or more importantly, a coral organism that builds calcium carbonate as part of its exoskeleton. If it's dissolving as it's growing, it can't survive. And so marine systems like coral reefs are particularly vulnerable to ocean acidification, and they're also vulnerable to the twin problem, which is the one we've just been talking about, which is warming. So when you put carbon dioxide in the air, you get global warming, which causes climate change, but you also get acidification. Coral reefs are very vulnerable to both of those things. And the reason coral reefs are vulnerable to warming is that the coral organisms have, in association with them, this is what gives them their color, an algae. You may have seen the Disney film that talks about coral reefs, and it goes into this. That algae is a mutualism. It's a relationship has a relationship with the coral that feeds that coral, allows it to survive. And that algae can only live within the coral within a certain temperature range. And when you increase the temperature of the water, the algae leaves the coral and it becomes white, and that's called coral bleaching. Coral is still alive, but it doesn't have its algae to help it survive. And 1 or 2 years of having lost its algae during the hot part of the year, the coral starts to die. And just in the news this morning, there was reports that this was a particularly bad year for the Great Barrier Reef, and that there's been tremendous amounts of bleaching. More than half of the Great Barrier Reef experiences bleaching, and now they believe that large portions of it will be dying in the next year or two if this pattern persists. So it's systems like coral reefs that are already very sensitive to changes in temperature, changes in acidification of the water that we're most worried about in the immediate future when it comes to the ecological effects of what we've been talking about.
So is it kind of like the canary in the coal mine? It's a little bit, it's a warning to us that things are getting warmer, that we're at greater risk?
Very much so. And so sort of an analogous fashion around here, I do research down at the Arnold Air Force Base, which is very close to us here. And in the middle of the base, there's this wetland forest called Sinking Pond. It's a large area that sits over a sinkhole. It's basically a wetland that has a population of trees in it that are quite rare. This population of trees is able to survive in this wetland because the amount of water that comes and goes over the course of the year. This is an ephemeral wetland, so it's dry for part of the year and wet for the other part of the year. The amount of water that's in this wetland and over the course of the year is determined by how much rainfall there is in the region. And one of the consequences of climate change for us here in Middle Tennessee is the effect that it has on the amount of rainfall. And I don't think anyone has to convince themselves we're having more rainfall than usual.
Oh, yes.
The past 2 years, and that is the expectation here. So remember, climate is both temperature and rainfall, and warming affects both. Our experience will be that we have greater rainfall. And so in this wetland, we're seeing the increased rainfall has created a situation where the system is experiencing more water than they ever had in the past 100 years or so, and that's causing trees to no longer be able to regenerate. So this forest of rare trees, it's in this pond that serves as the second largest blue heron rookery in the state. These trees, as they die, are not being replaced, and slowly this forest is turning from a forested wetland to an open wetland. And that's, again, one of these tipping point systems. It's, the first system is to, as you said, to register as a canary in the coal mine for the consequences that come are going to be those that are already on the edge. They're already sort of, on the border between changing and or not changing. And when you affect something like rainfall or temperature, they're the first to go.
So we could have, you could have predicted all this rain this winter, or is it just, it could have been predicted, or did it just happen and so we see this as a trend? Or could we expect a drought in the middle of the summer once my tomatoes come up?
Both. So again, the thing that we know about climate change, the one thing that we're certain of is that we can be uncertain in the future about what to expect. So we know that the climate models predict, in general, that over the long haul for Middle Tennessee, we're going to get greater amounts of rain. And that certainly is bearing itself out with weather patterns that we've had over the last 10 years. The trends are very clear. If you look at the Tullahoma rainfall records, we've had greater amounts of rain than we've had in any time in the past 100 years or so. So that tells us that there is a trend there. But again, you got to be careful. Weather is not climate. So any one event doesn't tell you that we're experiencing climate change. It's the cumulative, collective patterns that emerge that would tell us that. And what? So your example of a drought. So that's the kind of thing that we can expect with climate change, are these extreme weather events as well. So in the course of a year where we may have higher than average rainfall, we could also experience more extreme other types of weather events, such as droughts, or such as early or late frost, or early frost, or things that we just, again, combinations of weather, temperature and rainfall that we've never had in the past. And again, that's what I mean by this.
How about tornadoes?
Very possible. Extreme weather events are going to increase when you increase the amount of heat in the air and you change, the conditions in which weather plays out. Sort of storm events are part of that equation that we, but again, we can't predict the pattern, and that's what makes it scary, not only for our understanding of ecological systems, but also for our ability to plan for its effect on human systems.
Mm-hmm. How about just the general forested areas that we have in the valley and plateau in Middle Tennessee? Is there growth or root systems or anything affected by the climate changes in climate, the temperature?
Well, I think that, the interesting thing about our area here, and I spent some time on a task force working with the Nature Conservancy where we were looking at the whole southeastern United States and where, if we're going to invest money for protecting ecological systems going forward, of course, the Nature Conservancy is in the business, as is other organizations, for conserving lands for the purposes of protecting the species that are there. What they were interested in is where is the best investment of their money. So if they're going to raise money for the purposes of creating nature preserves, what is the best return on their investment in the southeast? Well, one of the scary things that they did was they blacked out the coastline. So that means that they're not seeing the coastline as a place to invest money. And why? Because of sea level rise, which is another consequence of global warming. Of course, we know that that's a function of the ice caps melting and causing greater coastal flooding. And so the unpredictability of these coastal systems and the possibility of their being flooded and experiencing dramatic ecological change, places like the Everglades, results in their perceiving these areas as not worth investing in the next 100 years or so. So you can invest in these lands. You want to make sure that the biodiversity that you're protecting will be there for the long haul. So those areas got blacked out. One of the areas on the opposite side of the equation that were expected to be more stable and that could be more resilient to the effects of climate change were the southern Appalachians, specifically the southern Cumberland Plateau region here where the university is located. And one of the reasons why this area is perceived to be so resilient is that we have a diversity with the landscape that it is, it's mountainous, and also with the diversity of soil types as a function of the various kinds of rocks that are present here across this topography. We have a variety of ecological conditions that species can shift around within. So as change occurs, what's important for species is that they be able to adjust their distributions appropriately to find new niches, if you will, that are equivalent to the way things that were in the past, and those might be higher up in a mountain, or or in an area that's wetter than perhaps it was in the past. And so this landscape here on the Cumberland Plateau provides the ability for species to move around, partly because the forest is still in good shape, it's intact. And one of the scary things about climate change is how it interacts with other threats that we generate as a function of our activities. And probably the most significant one up until now that's affected forests in Tennessee is land use change, the clearing of forests for activities, whether it be for development or whether it be for agriculture or forestry monocultures. And so when we fragment our forests and when we destroy forests, we prevent that landscape from being able to be resilient in the ways I've described. So it's important that we recognize that these different ways in which we threaten our systems, they can work synergistically, additively, to impact what we're trying to accomplish.
So a monoculture would that be taking down the forest to plant just pine trees?
That's correct.
Okay.
So one of the unfortunate things that happened on the Cumberland Plateau in the past, it started in the 1960s and really sort of tailed off in the 2000s, was the conversion of the hardwood forest, this natural, highly diverse forest on top of the plateau. Large timber companies bought up vast tracts of land and eliminated the native forests and created these monocultures of these plantations of loblolly pine. And loblolly pine, basically replacing this highly diverse forest with one species, was bad enough, but that species happened to be a species that was vulnerable to a natural disturbance regime, the southern pine bark beetle, which was present in our forests affecting native pines. When you planted all this pine in vast arrays across this landscape, you created this smorgasbord for the pine bark beetle. And so in 1999, 2000, when it was time for the pine bark beetle to come back, there was large amounts of pine present in its habitat, and it just it became an epidemic. And not only did it eliminate large amounts of these pine plantations, but it jumped into the forest and eliminated a lot of the native pine as well. And this is an interesting phenomenon, because the reason the pine bark beetle was so successful in that year was not only was there all this pine that had replaced the native forest due to this forestry activity, but it was warmer. So with climate change, as the temperature of the Earth got warmer, so did this region's average temperature, and that has allowed the pine bark beetle to spread northward and to be more impactful in its in the way it interacts with forests in this region. Typically, the pine bark beetle is found further south, but it's been moving northward, and so it was sort of the perfect storm that year, to 1999, 2000. You had a situation where the pine bark beetle had moved northward. You had all this pine sitting there as as basically
Beast.
waiting to be affected by the beetle. And as a result, there was vast amounts of mortality. The state lost millions and millions of dollars in the loss of this pine during those years. All could have been predicted. All could have been avoided if we had used our understanding of science and guided forestry activities such that they could have been more sustainable at the time. But unfortunately, it was corporations and their corporate profits that dictated the future of that land use. And as a result, these highly resilient forests on the plateau, large areas of it were lost, and that's too bad, because otherwise, these forests would have been very, very resilient to the effects that we're now seeing with climate change. But still, there is large amounts of forest that remain here. We're in pretty good shape up here in terms of our ability to see these systems resist the effects of climate change. Not so much in other parts of the world or other parts of this country. Obviously, we've seen the effects that climate change has had in the western forests with increase in fires, farther north in the boreal, melting of the permafrost and the changes that are occurring up there. Much more dramatic, much scarier in terms of the more immediate ecological consequences that we're gonna start to see and are seeing.
Okay. How about are any of these organisms or diseases affecting our animals, our deer, other other wildlife that may be endangered because of warming?
Well, all these
Or changes.
systems that collectively make up what we think of as the natural landscape of this region. They're composed of many species, plants and animals, that interact in complicated and diverse ways. And one example in which climate change can affect animals, for example, the relationship between animals and plants, would be one of the things that happened in 2007 in this weird playing out of weather that we can expect to have with climate change. So in 2007, we had a very early spring. Things warmed up, and by mid-March on the Cumberland Plateau, in an unusual sort of way, not unprecedented, but an unusual sort of early warm-up. And so leaves came out and insects came out, flowers were blooming, and then in early April we had a frost, a fairly hard frost, not unexpected. The last frost on the plateau really is, the Farmer's Almanac will tell you it's usually, it can be as late as April 15th. But because we had this early warm-up, a lot of species just were caught literally with their pants down, right? And so the frost hit, the leaves were killed, flowers were liquefied, butterflies dropped out of the air dead with the frost, all because the timing wasn't right? So you had this situation where there was this, the species that were present in the system here were not had not evolved the ability to have that sort of situation occur where you'd have this hard frost after you've already put out all these leaves and put out these flowers. Well, what that means is that you had a situation then where a lot of plants didn't produce fruits that year. Mm-hmm. Well, down the line, that can result in lower food supply for birds and for mammals and deer, and that could impact those populations. Also, and then the reason why they didn't produce fruits is that the pollination didn't occur. Either the flowers were killed or there was a break in the dance between the timing of the pollinators and the timing of the flowers, which is another sort of thing that's playing out elsewhere all around the world. Those are cued by temperature, and so when you have these conditions occur, you have this ripple effect through ecological systems where or what may be apparent just one or two or some species affected, actually it's because all species are related in a system. There is this snowball effect where the overall ecological impact can be quite great and unpredictable, and it's the unpredictability that's scary and should be humbling to us all. In fact, we really don't know how these things will play out until they actually play out. Like big natural experiments in this non-analogous world that we're moving into.
How about impact on water quality? Are there more, does the unpredictability reach as far as our water supply with, I don't know, maybe bacteria or the blooms of algae that happen in Florida? Do we have any problems like that in our streams and
well, we don't have that here so much. I mean, I think one of the things that we're seeing with warming in marine systems, I think you mentioned the red tide, other kinds of algal blooms. The the real problem that that we have with where our water ends up, where all this water here in Middle Tennessee goes into the Tennessee River, which goes down the Mississippi and then ends up flowing out into the Gulf. Well, as it moves through our landscape, it picks up, large amounts of nitrogen fertilizers and phosphorus in our, that get dumped into systems as a result of our activities, treated sewage water and all that. Eventually, all that water, as it makes its way out into the Gulf, it's laden with all these nutrients, and when it gets out there, it causes an algal bloom. The algae basically is stimulated by these excess nutrients, and this happens during the summer. And when that algae grows, it takes oxygen out of the water, and then it dies. It takes more oxygen out of the water because the bacteria that feed on that dead algae also require oxygen, and that creates this dead zone where there's this low oxygen, large areas of the Gulf, and that's exacerbated by the fact that the Gulf waters are increasingly warmer as a result of global warming. So with warmer water, you have less and less oxygen that can be stored in the water. So colder water has more oxygen in it, while warmer water has less. So it's this again, it's sort of a perfect storm of situations where you've got low oxygen at a time when there's already going to be low oxygen because the water's warm, and it's going to get even warmer as we warm the Earth. We're seeing vast areas of the Gulf in the summertime experiencing these what we call dead zones, where just life can't exist. Fish die. There's just no life there at all, and that's quite scary. And that's not one of these. You talk about climate change. Climate change is most impactful when it interacts with other threats. In this case, it's pollution. It's nitrogen pollution in our water, but it's with global warming and nitrogen pollution together, you get this combined effect, which is greater than either of them alone. And this is the kind of thing that you see playing out in systems in various ways all around the world.
And this eventually has an effect on us as humans, because we interact
absolutely.
with. Yeah.
I mean, we depend on the Gulf for our fish, the fishermen and the folks that that have various economic ties to the Gulf are going to be tremendously affected.
And of course, with hotter summers, we get some heat-related illnesses from extreme heat. Of course, we talked a little bit about tornadoes cause injuries, fatalities, air pollution, asthma, cardiovascular disease, and then some stress and anxiety when the weather is bad or we lose our homes. It treats people unequally, where we're going to see more changes with people that are, have less financial resources or getting out of the state a little bit more, coastal areas, people living in coastal areas, and it just affects everything, doesn't it?
It does, and I think that probably the most immediate and scariest effect of global warming is sea level rise, because we now know that that the world's oceans are rising at a more rapid rate than we even believed 10 years ago due to the melting of the polar ice caps. And most of the world's population lives within just a few meters of sea level. So if you increase that even by a little bit, just say a meter, you're going to start to impact large numbers of people on their economic well-being. And those people are going to have to move. Where are they going to move to? They're going to move to places where other people are. And that causes conflict, and that causes stress in social systems. And as these play out, as you indicated, it's there's a whole new set of concerns that are going to start to arise.
Right, with the migration, civil conflict, mental health issues. We're already under a lot of stress with this little virus going around, but this is just another thing to worry about. I'm sorry, folks. If anybody wants to call in, with a question or clarification for Dr. Evans, it's the number here is 931-967-2201. You know, Dr. Evans, some people don't believe this is has anything to do with us, that it's not man-made, that it's just one of those things, the climate warms, it gets colder. What did you say to people as a scientist? What's your short elevator speech about why climate change is real and why we've caused it?
Well, I think it's not unreasonable to expect that there's going to be people that do not understand this. It's the physics involved in climate change is not something you necessarily get, in your normal public education. I'm hoping more and more now will be training folks to understand the basis of this. But whenever you've got something invisible like carbon dioxide or a virus, you can't see it, you can't touch it, and yet its effects are slow but cumulative over time, and there's your particular involvement isn't necessarily generating a cause and effect that can be defined. That leads to large amounts of doubt in society and large amounts of skepticism, right? Because you can't pin it, you can't see it, and if you don't understand it, then you're easily swayed by arguments of people that have other interests at play. And what I would say is that we have to trust the scientists. We have to trust. We've relied on science in society for so many things, and it has done well for us. It's given us the technology that we're able to have this conversation on. I'm talking on a phone, and you're transmitting, in a radio. That's all science, and we have to trust the fact that science is going to, help us here navigate these changes going forward. And if we don't trust the scientists, we do that at our peril.
Right. So what do we need to do? What do we need to stop this cycle that's happening in our world?
Well, it boils down to the root of what we've been talking about, and that is, how do we lower the amount of carbon dioxide that we're putting into the air? And if the chief culprit of increased CO2, carbon dioxide, is the burning of fossil fuels, then we have to figure out a way to do less of that. And that is where we have the good news is we have options ahead of us in society that we didn't have in the past that are bearing fruit all around the world. Alternative energy sources and ways of even using different types of fossil fuels that are less impactful than others in ways that allow us to transition to alternative fuels. We have the ability and the technology to start to move to a carbon-free world, but we have to be willing to start very soon to put into place these policies that'll move us in that direction. And hopefully, that's something that we as a society can agree to do. If not, then inevitably these effects that we've been talking about will keep increasing to the point where eventually we'll be forced to have to do something, and at that point it will be too late.
Right. John, we have a phone call, a question, and we've got a highly technical setup here, so I'm good. Hi, this is Common Sense Matters. Do you have a question?
Hi. Can you hear me?
Uh-huh. Can you hear John?
I just wanted to ask Professor Evans there and I think he's already touched on it just now. My question is what ordinary citizens can do and say to influence our politicians, because even in this coronavirus legislation that's just passed, there was a lot of quarrel about, there was an extra thing inserted into it about monies for solar and wind industries. I don't know right now if it has passed because it was last night. I don't know if it got in the legislation or not. But I just wondered what ordinary citizens can do as far as what they can say when they call their politicians to influence them, to make them understand what is happening in our world. And I appreciate the Democratic Party for having Professor Evans on, and I'll hang up and you can answer my question.
Okay.
Thank you.
Yes, well, I did hear the question, and it's a
thank
good
you.
question. The most important thing I think everybody can do is first understand the problem, be able to communicate it in effective ways to others, and then be able to convince others and to engage the political system in such a way as to help bring about policies such as we described that will help to ameliorate the problem. And the most simplest way that you can do that is to vote for candidates who espouse those policies that reflect, the scientific reality of climate change. So those candidates and those politicians that are refusing to acknowledge the science or refusing to acknowledge the problem, they have to be replaced with people that get it. And it's that simple and that important. And again, the challenge, though, is that this is one of these things where, we're not immediately experiencing the dramatic consequences of climate change that our grandchildren will experience. When our grandchildren have no coral reefs, and when the Everglades are gone, and cities are experiencing flooding, and all these things that are going to happen, down the line, will have been the ones that will point to this. And why didn't you do what you should have done? Why didn't you put into place those policies that allowed us to have a sustainable world? And that's how do you instill that kind of responsibility in society? It's person to person. It's people convincing each other and collectively letting our politicians know that we care and that we expect them to do what is best. And but that starts with individuals, and you can also through your own individual behavior manifest an example to others. Lower your carbon footprint, and in doing that, you practice what you preach.
Well, I think that the first step is knowledge. Like you said earlier, this wasn't in our textbooks for many of us. And I've suggested in the past for people to steal their grandchildren's science book or their science assignment, because they know all about this. Or just talk to your children, what are you learning about climate change? And I think they'll tell you because they know it and they're concerned about it. And so programs like this and podcasts and documentaries and things like that to start there, so that when you talk to you, and you're the one that said this is on another occasion, that don't just ask them, the elected officials, do they support environmental sustainability. They're not going to say no, right? You're going to say yes. So you have to ask them a few more questions and hold their feet to the fire. And unfortunately, I believe that in our communities here in Tennessee, consistently we don't get listened to. I don't know if it's just because we're the minority or the right questions aren't getting asked or whatever, but we feel a real sense of nobody listens to us as Democrats, as people that are concerned about this with our leaders. So you just have to hammer and hammer and hammer away. And I have some closing comments about that too. So good question. Thank you. Anybody else has a question? We're at 931-967. Check on the time here. So we were talking about lowering our carbon footprint. The caller also mentioned, there are ways to do that with wind, solar, nuclear. I'm not sure. Hydroelectric dams. I think some of these do take some energy. Is that right? It would still be some dependence on fossil fuels.
Right. So different energy sources have different consequences, and we have to be careful when we start to look at what our alternatives are, that we don't go from bad to worse, or we don't replace one problem with another. Mm-hmm. And the argument with nuclear is that there are a lot of problems with nuclear power. Obviously, it is a energy source that doesn't require fossil fuels, but it has all kinds of other issues associated with it that have societal consequences, and the most significant of which is the expense, the cost of insuring these nuclear power plants and the maintenance and management of them is the reason why most energy companies, private companies around the country, have not invested in these plants over the last 30, 40 years. It's really only the massive government subsidies that's allowed them to persist at all. That's not really, in the current technology with nuclear power, is not really our future. I think we have to look beyond that and do what other countries around the world are doing and massively invest in alternative sources like solar and wind, which are, in places like China and Germany and elsewhere, are making huge strides in replacing fossil fuels. And it's a collective will in society to start the investment in that direction. We didn't magically have cell phones and calculators and computers just overnight. It was government investment in these technologies, partly as a result of our space program, that allowed those government investment that allowed us to make huge headway and become a world leader in these technologies. Mm-hmm. We could become a world leader again if we put our collective will into trying to achieve what's necessary to make these viable, not only in our country but around the world. And I think we've lost that edge right now, mm-hmm. but we could gain it if we asked and demanded of our government that it participate in that way.
Mm-hmm, mm-hmm. Now, natural gas, is that considered a fossil fuel? So
it is. It's an interesting one. So methane, natural gas, the difference. So as I said, not all fossil fuels are equal in terms of their environmental impacts. Natural gas, when it burns, people say it burns clean. That's because when you burn natural gas, you basically get carbon dioxide and water. When you burn coal, which is another fossil fuel, you get not only water and carbon dioxide, but you get a whole lot of other things. You get arsenic, and you get you get other sulfur and nitrogen and put up into the air. And all of these have pollution effects that cause impacts on our health, and acid rain and other consequences, and water pollution that burning natural gas does not have. But nonetheless, natural gas puts carbon dioxide into the air. And also the fracking for natural gas and the extraction of methane results in loss of methane into the air. It escapes. You don't capture it all because it's a gas and it's very hard to get it. And methane is 10 times more potent as a greenhouse gas than carbon dioxide. So for every molecule of methane you put up in the air, it's like 10 times more potent in trapping heat on this planet than carbon dioxide. So we have to be very, very careful, and you've probably seen that in the news, that the world's extraction of methane is contributing to global warming. Mm-hmm. Not only in addition to the burning of that methane, which increases carbon dioxide, but it's a better alternative fossil fuel than petroleum or coal.
Cool. Okay. And the caller asked about, in addition to how we could persuade our elected officials, or demand, to use a stronger word, but to do personally, is, I think, to make our homes more efficient. And I have to say, the homes smaller. The homes just get bigger and bigger, and that takes energy, probably not wind or solar, to heat them. And but you still have tight windows, and the most environmental home is not a new one, but the old one revisited. Is that correct? Would you say that is a good personal thing that we can do to control the
Yes, I mean, we have
change?
All kinds of ways in our homes that we can decrease our carbon footprint. As you mentioned, insulation and just how you place your house in terms of having tree cover, so you're not using as much air conditioning as one would need. Using LED light bulbs, I mean, it has a huge impact on the amount of energy that's consumed collectively by the American society. So we have many ways today in which we can lower the amount of energy that we actually consume on a daily basis if we're willing to look into it and to aggressively do our bit to generate less carbon dioxide through our energy usage.
But certainly to try to make things happen on a big scale, a government scale. How do your students feel about the future?
Well, right now our students are all sequestered away in their homes. The university has gone into a very unusual mode of doing remote teaching. We don't have any students on campus. Well, there's a few here who can't go home for various reasons, but we're not teaching live classes. We're teaching our classes remotely using computer technology, which is a challenge for all of us, but we're managing. I think most schools around the country have gone into this mode, and it's a scary time for everybody. I think because while you're trying to achieve education through these new means, students are trying to figure out their own futures and their immediate future in terms of their safety and well-being, and so it's stressful. I think it's.
But before they left,
we've never had experienced before.
Before this latest crisis, were they hopeful about the future? Did they feel like there was a place for them to make a difference? Your biology, your environmental sustainability students?
I think there's a lot of concern out there. When I teach courses that relate to conservation and climate change, they're packed with waiting lists, and this generation gets the fact. This younger generation gets the fact that they're going to have to deal with the consequences, and probably also have to, take the baton on continuing to try to solve the problems. And it's they're in the thick of it. It's no longer a future thing that we should ponder. It's happening now, and I think they recognize that they're the ones that are going to have to engage but also endure in terms of what the implications are. And there's a lot of anxiety. I think there's a lot of concern, and rightly so.
Okay. John, I just wanted to conclude with a few statements, and if you have a minute to back me up on this, because it's some things that we've talked about. Is that okay?
Sure.
Okay. Again, sorry to add to everybody's worries with another potential crisis when we're going through the coronavirus pandemic. I hope that listeners to both this and what we'll put as our podcast on Facebook, that you're keeping up with the COVID-19 news from a reliable source. The Tennessean, the Chattanooga Times-Free Press, the New York Times, NPR. Unfortunately, I can't encourage you to go to the library to read these papers because even the library's closed. So a subscription online or delivery is necessary. There's also many good podcasts that are free. The Daily, which is with the New York Times, Can He Do That?, the Washington Post, and really any podcast from NPR if you go to iTunes or Google Play. Also, if you don't know, Now You Know is a podcast by the Tennessee Democratic Party that's excellent. Mary Mancini has been able to get good guests on from the Nashville area. Also, What About Us is my podcast. It's a look at how policies affect rural Tennesseans. Also, articles on the Franklin County Democratic Party Facebook page and the Franklin County Democratic Women. That's at Franklin County, parentheses, TN, close parentheses, awesome Democratic women with state issues. Again, all the topics you can read and learn, and then take one or two pieces and write or call our elected officials. I would recommend keeping some pre-stamped postcards near your reading area and jot down a sentence or two and send it off. Be sure and include your name and complete address. This is not the time to just watch reruns, Netflix. We are experiencing a real crisis, despite what this administration and its supporters choose to believe. Please listen to the scientists. The problem with the COVID-19 virus is that it is highly contagious. There's not very much known about it except how it has affected other countries. There's no reason to believe that the U.S. will be different The difference is that despite the model of China, Italy, and now New York, our leaders have decided to ignore it or move at a glacial pace, lie about our risk and the availability of testing and resources. So that's my little thing about COVID. Do you have anything to add? John, I gave the scientists another heads up.
Well, I just would echo the fact that we have to hold our elected officials accountable. I mean, we have governments. So I think one of the things that's going to come out of this whole COVID crisis is we recognize that we need government in order to protect us. The governments are not there, that are the things that we just create to cause us problems, as some would have us believe. We put governments in place because we need that collective ability within society to provide protections at a time like this. And when those systems that we put in place fail us, it means our government officials are failing us, and it means we put the wrong people in there. And I think we're starting to see this play out. Is that we're woefully unprepared for this crisis because we didn't expect we didn't have the expectations we should have had for our government officials going into it. And so at the end of this whole thing, hopefully when we come out the other side, we'll make the appropriate changes.
Oh, did we lose you? I think John has left us. He just got cut off. John, you can call us back to finish that sentence. I want to also say a big shout out to the healthcare professionals who are working in New York, and no reason to believe this won't be crossing across the country. It's at the coast. We've got increasing cases in Nashville and Memphis. But there's a shortage of protective equipment. They're putting their lives on the line to save patients, and we never get enough support for them. Not just pats on the back, but the things that they need to do their job. This might be John calling back, but I want to just also mention some state issues. Governor Lee continues to add to his rainy day fund. I don't know what rainy day he's waiting for, but it's now $1.4.5 billion just sitting there to help the people of Tennessee. There's no plan for the uninsured. We're still waiting on a block grant funding waiver. The uninsured in Tennessee have been waiting 5 to 6 years with no end in sight. There was a bill in the legislature to look into Governor Haslam's 2015 Insured Tennessee. It's tabled while we wait and wait and wait. Advice to call your doctor and go to a hospital if you have coronavirus symptoms. Well, in rural Tennessee, what doctor, what hospital? Okay, the Democrats in the legislature at this session fought this. $40 million is still appropriated to go to vouchers for those private school tuitions instead of our public schools. The Democrats fought this. Oh, and teacher pay raises. I know that our party here in Franklin County has had Beth Brown in several formats talking about teacher salaries and how low we are in payment for teachers. Those pay raise percentages were slashed. Also in the budget originally, the Mental Health Trust Fund for K through 12 was eliminated. Again, the Democrats fought this. So it's our party, folks, and you can cry if you want to, but let's try to get into action during this time, because guess what? When this is over, and I think it'll be over someday, again, the scientists all over the world are looking for information about the virus, how to fight it, how to keep us safe. With all those scientific heads together, I'm very positive. But all the other bad stuff that our government has been trying to do, will be right back at it. And now we have to save another $2 trillion off the deficit. So I want to thank so much John Evans. He's a friend of mine. Dr. John Evans is a friend of mine. He's a great speaker. His students love him, and I hope that you can see why. Look for this on Common Sense Matters. It's on the website, and listen to it again, because I know it was a lot of It was a lot of information and science, but science is going to help us a lot. Thanks so much, Al, for having Common Sense Matters.
You're welcome very much. You're listening to WCDT AM 1340, W295 FM 106.9 in Winchester. It's 4 minutes past 9.
Well, a lot of sunshine today, which is good news. It's going to warm up to around 78, but looks like maybe rain's going to come back in before daybreak Friday morning, where we're going to see a little bit chance of rain in the morning part.